Hey, this is John Nelson, and welcome back to my Week 4 Advanced Financial Modeling exercises. Sorry for the late submission. I had an ankle injury, and Mr. Huang gave me an extension because I couldn't exactly figure out NumPy and Pandas, like how to import them into my terminal and then run the Python. So first, I'm going to show you my 3 first screenshots. I'm not going to go into very much detail, but here is me using NumPy is NP, NumPy Financial is NPF, and then Pandas. I could run the first 2 exercises with this, but I kept running into errors whenever I kept trying. It would like mix up the different NumPys. So I ended up going with a different strategy and using math, import math, and import statistics. So as you can see from this screenshot on Terminal 1, Week 4, Attempt 2, you import math, import statistics, and then you have your financial calculations for present value, future value, net present value, and internal rate of efficiency, or internal rate of return, IRR, internal rate of return. So calculate present value, future amount, and then param, FV, param, rate, param, periods, param, return, present value. Future value, same thing, param PV, present value, param rate, interest rate per period, param periods, number of periods, return, future value. Net present value, calculate net present, param cash flows, list of cash flows, param rate, discount rate, return, NPV. Internal rate of returns, calculate internal rate of returns, param cash flows, list of cash flows, param max, iterations, maximum number of iterations, and then PARM, tolerance level of convergence, return, IRR, initial return, rate of returns. So I'm going to get to the terminals at the very end to go over everything at once. So if we look at line 46 on this screenshot, I kind of hovered over it, so it kind of got messed up for a second, but no problem. Guess equals 0.1 for in range max iterations, and PV equals sum, parentheses, CF divided by 1 plus guess times I, parentheses, for I, CF in enumerate, which is cash flows. Then derivative, obviously, equals sum, negative I times CF divided by 1 plus guess times I plus 1. For I, same thing, CF in enumerate, cash flows. New guess equals guess minus NPV divided by derivative. And then if abs new guess minus guess is less than tolerance, return new guess, guess equals new guess, return guess. So now we need to look at stock metrics. Def, daily returns, prices. Calculate daily returns of a list of stock prices, param prices, a list of stock prices, return list of daily returns. So then the returns will be for I in range 1, lin prices, returns dot append prices I minus 1 divided by prices I minus 1, return returns. Then volatility, def volatility returns, calculate the volatility standard deviation of returns, param returns, list of returns, return volatility standard deviation, return statistics standard deviation returns. Then Sharpe ratio, def Sharpe ratio returns risk-free rate. Calculate the Sharpe returns, param returns, list of returns, param risk-free rate, returns Sharpe ratio. Mean underscore return equals statistics dot mean parentheses returns, return parentheses mean return minus risk-free rate backslash volatility return. So now on line 87, we can look at bond pricing. Def bond price is face value, coupon rate, years to maturity, and market rate. I believe that is all. Yes. So you calculate the current price of a bond, PARM face value of the bond, PARM coupon rate, annual coupon rate as a decimal, PARM years to maturity, and PARM market rate, market interest rate as a decimal. Return will be the bond price. Coupon payment equals face value times coupon rate. So price equals 0. For T in range 1, years to maturity plus 1, price is plus or equal to coupon payment divided by 1 plus marketplace times T. price plus or equal to face value divided by 1 plus market rate times year to maturity, and then return price. For portfolio analysis, it's DEF portfolio analysis, stock prices and weights. So analyze portfolio of stocks, PARM stock prices, and PARM weights. List of lists where each inner list contains prices for a stock. That gets a little cut off. And then lists of weights for each stock in the portfolio. Return dictionary with portfolio return and risk. Portfolio returns equals the brackets. For I in range, Lynn stock price is 0 minus 1. Daily return equals 0. For J in range, Lynn stock prices, daily return plus or equals weight J times stock price is J 1 or J I plus 1 minus stocks. Portfolio returns append daily return. Portfolio return equals statistics dot mean portfolio returns, and then portfolio risk statistics dot standard deviation portfolio returns. So return, portfolio return, portfolio return, portfolio risk, portfolio risk. So now we can look at line 124 for loan amortization. DEF loan amortization principal annual year or annual rate in years. Generate a loan amortization schedule, PARM principal loan amount, PARM annual rate, annual interest rate as a decimal. PARM years, loan term in years, return list of dictionaries representing the payment schedule. Monthly rate equals annual rate divided by 12, months, years times 12. Monthly payments equals principal times monthly rate divided by 1 minus 1 plus monthly rate times negative months. Schedule equals brackets, remaining balance equals principal. For month in range 1 months plus 1, interest payment equals remaining balance times monthly rate. Principal payment equals monthly payment minus interest payment. Remaining balance equals principal payment, or minus or equals principal payment. Schedule dot append month payment, monthly payment, principal payments, interest payment, remaining balance. That's part of the schedule. And then return schedule. Then we have risk metrics, DEF, beta, stock returns, and market returns. Calculate the beta of stock, PARM stock returns, list of stock returns, PARM market returns, list of market returns, return beta. Covariance equals sum S minus statistics dot mean stock returns times M minus statistics mean, it kind of gets cut off here, times market returns for S, M in zip stock returns, market returns divided by Lynn stock returns. Then we have market variance equals statistics variance, market returns, and then return covariance divided by market variance. DEF standard deviations next, returns. Calculate the standard deviation of returns, PARM returns, list of returns, and then return standard deviation. Return statistics, standard deviation. And then finally, if we look at line 173, example usage, if name equals main. This is pretty much for the example usage of functions. Print, it's printing everything back out into our terminal. Print present value, print future value, print net present value, print internal rate of return, daily returns, volatility, Sharpe ratio, bond price, portfolio analysis, loan amortization, beta, and standard deviation. I couldn't get it to go unless I did it all in one, which is really weird, but it took me a long time to do this assignment. So now let's look at the terminal. The terminal is a quick glance. As we can see, I just pulled it all up here. We get the present value, 783.53 rounded up. That's the same as the NumPy and Pandas version I did at the very beginning. We get the same values. Future value, 1,276.28. Net present value, 219.47. Internal rate of return, 0.128257, etc. Daily returns, 0.02, 0.0294, 0.019047, 0.020837. Volatility is only 0.00816. That's a low one. Sharpe ratio, 1.22474, etc. Bond price, 1,081.10895, etc. Portfolio analysis. Portfolio return was 0.0247. Portfolio risk was 0.031119. Then we can see here our loan amortization goes all the way down this section right here. It goes all the way to month 22. And as we look at this next screenshot, we can see it goes all the way down to 60 full months, with the last remaining balance being negative 4.402522. But our beta is 0.6 repeated along the line, and then our standard deviation is simple as 0.01. Thank you so much for watching my week 4 advanced financial modeling video, and I will see you soon because I'm doing my week 5 one next.